Unit 4, Lesson 6, Features of Graphs. Learning target number 1. I can identify important features of graphs of functions and explain what they mean in the situations represented. Learning target number 2. I understand and can use the terms horizontal intercept, vertical intercept, maximum, and minimum when talking about functions and their graphs. This graph represents Andre's distance from his bicycle as he walks in a park. Decide whether the following statements are true or false. Number 1. The graph has multiple horizontal intercepts. So when we look at a graph, the left to right axis is the horizontal axis. And an intercept means the graph touches the horizontal axis. And we see that happen right here, down at about 0.5, and we see it happen down here at about 27. So there are two horizontal intercepts, so number 1 is true. Number 2, a horizontal intercept of the graph represents the time when Andre was with his bike. If you notice, it says this graph represents Andre's distance from his bicycle as he walks in a park. And we see that time is the horizontal axis, and we see that distance is the vertical axis. So when our vertical distance is 0, that means Andre is with his bicycle. So this would represent that Andre is with his bicycle for the first half a second, and then he is back with his bicycle at about 27 seconds. So number 2 is true. Number 3, a minimum of the graph is 17.1. So they are talking about this point right here at 17.1. If this were a minimum, it would have the smallest y value. So we know this can't be a minimum because there is a minimum here at y equals 0 when Andre is with his bike. And there is another minimum over here at y equals 0 when Andre gets back to his bike. So number 3 is false. Number 4, the graph has two maximums. A maximum is a point on the graph where the y value is the greatest. If you look at the top of the first hill, we see that the line is even with y equals 8. But if you look at the second hill, you can actually see there is space between the top of this hill and the line that represents 8. So this hill is actually slightly higher and is actually the 1 maximum. So number 4 would also be false. Number 5. About 21 seconds after he left his bike, he was the farthest away from it at about 8.3 feet. So 21 seconds means we go to the right until we hit 21, and then we go up to that point that we just declared the maximum, slightly above 8 feet. So 8.3 feet could be correct. So number 5 is true. The graph represents the temperature in degrees Fahrenheit as a function of time. Tell the story of the temperature throughout the day. Identify the maximum and minimum of the function and where the function is increasing and decreasing. So we have one minimum down here at the beginning of the time. Then we can see it increasing quickly until noon. From noon until 3, it continues increasing, but at a slower rate until it reaches the maximum temperature at 3 p.m. After 3 p.m., we see the temperature begin to decrease until about 7 p.m., at which time it begins decreasing at a faster rate until the other minimum here at 9 p.m. So we have a minimum at the beginning, a maximum around 3 p.m., and the other minimum around 9 p.m. Match each feature of the situation with a corresponding statement in function notation. A is looking for the maximum height. So if we look, the x-axis is time and the y-axis is height. So if we want the maximum height, that's going to be right here at 16 feet. That happens when the time is 4. So if I was matching this up, the maximum height happens when the function has an input of 4 seconds. So A matches 3. B is looking for a minimum height. So we want the lowest y value, which happens right here when the input is about 1.5. So the minimum height would be when the function uses an input of 1.5. B matches 2. C is looking for the height staying the same. We see that down here on the end when time is between 7 seconds and 8 seconds. And we can see that the height is halfway between 4 and 8, so we would say that's about 6. Therefore, C matches 4. The function at a given time equals 6 when the time is between 7 and 8 seconds, including 7 and 8 seconds. And lastly, we're looking for the starting height. That would be the point here on the vertical intercept. We can see that time is 0 and height is approximately 7. So D matches description 1. Here are the equations that define 3 functions. We have function f equals 4x minus 5. Function g of x equals 4 times x minus 5. And function h of x equals x over 4 minus 5. Number 1, which function value is the largest? F of 100, g of 100, or h of 100? So f of 100 equals 4 times 100 minus 5, which equals 400 minus 5, which equals 395. G of 100 equals 4 times 100 minus 5, which equals 4 times 95, which equals 380. And finally, h of 100 equals 100 divided by 4 minus 5, which equals 25 minus 5, which equals 20. So which function value is the largest? That would be f of 100, because it equals 395 versus 380 for g of 100 and 20 for h of 100. Number 2, which function value is the largest? F of negative 100, g of negative 100, or h of negative 100? So f of negative 100 equals 4 times negative 100 minus 5, which equals negative 400 minus 5, which equals negative 405. G of negative 100 equals 4 times negative 100 minus 5, which equals 4 times negative 105, which equals negative 420. And h of negative 100 equals negative 100 divided by 4 minus 5, which equals negative 25 minus 5, which equals negative 30. Therefore, with a value of negative 30, h of negative 100 is the largest value. And finally, number 3, which function value is the largest? F of 1 over 100, g over 1 over 100, or h of 1 over 100. F of 1 over 100 equals 4 times 1 over 100 minus 5. That equals 4 over 100 minus 5, which equals 1/25 minus 125/25, which equals negative 124/25. Then we have g of 1 over 100, which equals 4 times 1 over 100 minus 5. That equals 4 times 1 over 100 minus 500 over 100, which equals 4 times negative 499 over 500. Four goes into 4 once. 4 goes into 500 125 times. So this becomes negative 499 over 125. And finally, h of 1 over 100 equals 1 over 100 over 4 minus 5. 1 over 100 divided by 4 becomes 1 over 100 times 1/4 minus 5. 1 over 100 times 1 over 4 is 1 over 400 minus 5. That becomes 1 over 400 minus 2,000 over 400, which equals negative 1,999 over 400. Now, if we are comparing these, f of 1 over 100 is just under negative 5. So that's approximately negative 5. Negative 499 over 125 is just approximately negative 4. And negative 1,999 divided by 400 is approximately negative 5. So the largest value is clearly G. And that is how we would find the answers to this problem. And the last practice problem in lesson 6, function f is defined by the equation f of x equals x squared. What is f of 2? To find this, we substitute 2 in for x. So this becomes 2 squared, which is 2 times 2, which equals 4. Number 2, what is f of 3? We take 3 and we substitute it in for x, and we get 3 squared. 3 squared means 3 times 3, which is 9. Now we need to explain why f of 2 plus f of 3 does not equal f of 5. The easy way to show this is we said that f of 2 equals 4, and we said that f of 3 equals 9. But if we take f of 5, then f of 5 equals 5 squared, which is 5 times 5, which equals 25. So if we substitute this in here, 4 plus 9 does not equal 25. Those are all the practice problems for lesson 6. If you still have any questions about this lesson, please be sure to use class time to ask those questions so you can get clarification before our mid-unit test.